Okay, we've discussed matrices, so now we're going to talk about a particular number associated with each matrix, and that's called the determinant, right? Every square matrix, so it's got to be an n by n, every square matrix is associated with a real number called the determinant of that matrix. And it's written with vertical bars, looks like absolute value bars. Matrices are written with brackets. When we're talking about determinants, we just use vertical bars. So the determinant of a 2 by 2 matrix looks like this. It's a cross multiply thing. So I'm going to multiply this times this minus this times this, right? That's the determinant. This times this minus this times this. Okay, we already mentioned this. Matrices are enclosed with square brackets. Determinants are enclosed with vertical bars. Okay, a matrix is an array of numbers, rows and columns, but its determinant is a single number. All right, so let's practice. Let's find the determinant of A. So that would mean if I'm finding the determinant, it's enclosed in vertical bars, and I would do this times this, right? Negative 3 times 8 minus this times this, 4 times 6. Okay, so that's the determinant of A single number. Okay, so 2 by 2s, they're real easy. Let's look at 3 by 3s. Okay. So if I'm going to find the determinant of a 3 by 3, I'm going to rewrite the matrix in determinant bars. And what I'm going to do, let's imagine there's a bar there. Well, let's put a bar there. Is I'm going to continue with the next, repeating these first two columns. And then it's similar to the 2 by 2 where it's this times this minus this times this, but I'm going to have 3 rows minus 3 diagonals. I shouldn't say rows, diagonals. Okay? So I'm going to multiply all 3 of these. If it's a 2 by 2, I do this times this minus this times this. But if it's a 3 by 3, this is why I had to expand it. I'm going to do these multiplied together. So negative 8 times 2, negative 16. Okay, positive 9, so negative 9 altogether. And then this is 0. So plus 0. I'm going to put it here for emphasis. And then it's minus this times this minus, and then I'm going to do the other direction. So I'm going to multiply these diagonals. All right, so minus, so I need my parenthesis there because I want to subtract every single one of these numbers. So minus positive 6, 0, I'll put it for emphasis, okay, negative 8. All right, so my determinant is negative 25 minus negative 2, or negative 25 plus 2, negative 23. Okay, it's a little more drawn out than a 2 by 2. 2 by 2's way easy. 3 by 3's fair. All right, we're going to practice this several more times because we're going to talk about, well, why do I need to do this? and we'll get some practice at that point. Okay, because the reason we need to do this is we're going to use something called Cramer's rule to help us solve a system of equations, linear equations. It only works for linear equations. So a system of linear equations. So I'm going to find what this is doing is explaining it. It might be better to just go do it and explain as we go along. But basically, I'm going to find a determinant, and then I'm going to find a d sub x, a d sub y, a d sub z. Let's just go along, and it's easier to explain that way. Okay, now caution, be careful. Cramer's rule does not apply if your very first determinant is 0. When d is 0, it means either there's an infinite number of solutions or no solutions. So always do plain determinant of d first, because if you get a 0, then there's no reason to keep doing determinants. You're done with Cramer's rule. Okay? So what that means is, and when it says use Cramer's rule, we got to use Cramer's rule. So use Cramer's rule to solve the system. So the first thing I'm going to do is I'm going to find just d. D is the determinant that's formed when I just use the coefficients of my variable terms. So 5, 6, 7, 8. Okay, so I'm going to find d. 5 times 8 is 40, minus 7 times 6 is 42. Okay, if this would have been 0, I would be done, and I'd say, oh, I can't use Cramer's rule, right? Because that either means there's no solution or infinite solutions. If I get a non-zero number right here, then I've got solutions. All right, so now I'm going to go in and I'm going to find d sub x. D sub x. That means I'm going to replace my x coefficient with the answers. Right? The y's are going to stay the same. Negative 8 minus 7, negative 15. And then I'm going to find d sub y, which means I'm going to replace the y's with the answers. The x's will stay the same. So this is 5 minus, be careful with your signs, minus 6, or 5 plus 6, 11. Now, once I have all of my determinants, my answers are found by x is found by doing d sub x divided by d, and y is found by doing d sub y divided by d. This is the reason that if you get a 0 for d, you can't use Cramer's rule. You can't have zeros in denominators. You can't have zeros in denominators. Okay, so d sub x is negative 15. D is negative 2. So this is 15 halves for x. D sub y is 11. D is negative 2. So negative 11 halves for y. That's my answer. 15 halves, negative 11 halves. So that's a nice addition to our methods, right? Cramer's rule. Okay. Let's do it for 3 variables. I just got to be careful with my work, right? So I'm going to do D. D means I'm going to make a matrix using, oh, look, I need those moved over first, right? Let's just do that right here because I don't hardly have any room here. So let's make this equals negative 2 equals negative 5 and equals 4, right? Just for emphasis so I don't miss these negatives here. Negative 2, negative 5. So put your constants on the other side. Anytime we are trying to solve a system, all right, let's put our constants on the other side. All right, so I'm going to make my first matrix with the coefficients of my variables, my x's, my y's, my z's. So 1, 2, 1. 1, -1, -2. And -1, 1, 3. So that I can do, oh, don't forget to expand it. Once you go try to do it, you'll realize, wait a minute, I don't have enough columns over here. So let's continue repeating those first two columns. Let's see if this is going to give us enough room. I hope it doesn't get too jumbled. All right, so I'm going to multiply all of this. Maybe I'll just, instead of circling them, let's just underline them to help save some room. Okay. So this is -3. And I'm even going to do this. Okay. -3 plus 1 plus 4. Now we're going to do minus, so don't forget your parenthesis. Okay, and then I'm going to go down these diagonals. Minus 6 minus 2 plus 1. Okay, which is 1 minus 4 or -3. All right, so there's D. Now I have to find D sub x. D sub x is going to be found by replacing the x coefficients with the answers. So -2, -5, 4. The y's and z's stay the same. So 1, -1, -2. Okay, -1, 1, 3. All right, now we're going to repeat these first two columns, -2, -5, 4, and 1, -1, -2. Okay, so go down my diagonals. And we'll see that that is 6 plus 4 minus 10 minus -15 plus 4 plus 4. So this equals 10 minus 10, 0, minus -15, -15 plus 8, so -7. So this determinant is 7. Okay, then we're going to do D sub y by replacing our y column with the answer column. So x stays the same, 1, 2, 1. Okay, y's get -2, -5, 4. Z's the same, -1, 1, 3. Okay, repeat your first two columns, 1, 2, 1, negative 2, negative 5, 4. All right, so that's going to equal negative 15 minus 2 minus 8, and then it's going to be minus negative 12 plus 4 plus 5. Right? So negative 15 minus 2 minus 8 minus 25 minus negative 12 plus 9, negative 3. So negative 25 plus 3 is negative 22. Okay. And then we would do d sub z. All right, since I'm running out of room here, I'm going to erase this. I'm just going to put over here that we have found our d sub x. Okay, d sub x is 7, and d sub y is negative 22. Okay, and now let's do d sub z, which means you replace the z column with your answer column. So this will stay the same, 1, 2, 1, 1, negative 2, and then negative 2, negative 5, 4. Okay, so there's that, but to find the determinant, I'm going to repeat these first two columns. 1, 2, 1, 1, negative 2. And then this will equal negative 4 minus 5 plus 8 minus the other direction. 8 plus 10 plus 2. Okay, so this determinant equals negative 9 plus 8, negative 1 minus 20, negative 21. So d sub z equals negative 21. Now I can find my answers. X equals 7 over negative 3. Y equals negative 22 over negative 3. So 22 thirds. And Z equals negative 21 over negative 3, or positive 7. X, Y, Z. Okay. Let's try that one more time, just for practice. Okay, so first thing we got to do is find D. So D is the determinant found by using the coefficients of the variables 2, 3, 1. negative 1, 2, 4, 4, negative 1, 2. Repeat the first two columns, 2, 3, 1, negative 1, 2, 4. Okay, so our determinant is going to be, right? Can we do it without putting the line? If you can't, but just for my sake here, it gets so jumbled up. So 8 plus 1 plus 12 times 4, 48. Minus, now let's do the opposite direction. Be careful you keep your diagonals straight. So negative 6 minus 8 plus 8. Okay, so this is 57 minus 6. So 57 plus 6, 63 is D. Okay, now we need D sub X, D sub Y, D sub Z. So D sub X, I'm going to replace the X coefficients with the answer column. So negative 2, negative 3, 17. And then the Y's and Z's stay the same. Negative 1, 2, 4, 4, negative 1, 2. Okay, let's replace or repeat the first two columns. Negative 2, negative 3, 17, negative 1, 2, 4, and see what we get. Okay, so negative 8 plus 17 minus 48, 12 times 4, minus 48. Now it's minus in the opposite direction. So 6 plus 8. Okay, 8 times 17, let's see, 136. Be sure you check your math, right? Yeah, that looks right. Okay. So we have 9 minus 48, so negative 39 minus 14, so 150. So minus 189. Okay. Now let's do D sub Y. Where I replace the Y's with my answer column. So 2, 3, 1. Negative 2, negative 3, 17. 4, negative 1, 2. Repeat the first two columns. 2, 3, 1. Negative 2, negative 3, 17. All right. So negative 12 plus 2. Okay, 12 times 17. So let's go over here and see what's 12 times 17. $204. Oh, no, 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 because, yeah. Okay, 34, 17, 204. Okay, plus, where are we at? This one, this one, this one. Okay, plus 204. Minus, now the opposite direction, negative 12 minus 34 minus 12. Okay, so that gives us 206 minus 12. What's that, 194? Let's make sure. 206 minus 12 is 194. Then we have minus. All these are negative, so we're really going to add them. Right? 24 and 34. So negative 58. So I would add this. So 252. 252. Okay, to make room, I'm going to have to erase this again. So let's keep track of, we have our d sub x that we found to be negative 189, and d sub y is 252. Okay. Now we just need d sub z. For d sub z, we do what? Replace the z column with the answer column. You're right. Hopefully that's what you said. Okay, so 231 stays the same. Negative 124. But the z is now negative 2, negative 3, 17. Let's repeat the first two columns. 2, 3, 1, negative 1, 2, 4. Okay. So this is 17 times 4, 68, plus 3, minus 24. Then we got to do minus the other direction. So negative 17 times 3 is 51, right? Negative 51 minus 24 minus 4. Okay. So 68 minus 24, 68 minus 24 is 44 plus 3, so that's 47 minus, these are all negative again, so I'm going to add them all together. So 55, 79 minus negative 79, so that means I'm going to add those, right? So 126. Okay. So now we can find our answers. Okay, because we also have found out that d sub z is 126. So that means that x equals negative 189 over 63, which, look at that, is negative 3. Y is 252 over 63, which is 4. Z is 126 over 63, which is 2. Negative 3, 4, 2. Awesome. Okay, let's look at the next one. It kind of tells you what's going to happen here, but normally you're not going to see that. So if it's saying solve this using Cramer's rule, that's what we would start out doing. So first thing we do always is do D. So 2, 6, 1. Negative 3, negative 9, 2. And 4, 12, negative 3. Now let's repeat the first two columns. 2, 6, 1. Negative 3, negative 9, 2. Okay. So we have positive 9 times 6 is 54. Minus 36 plus 48. And then it's minus the other direction. So there's 9 times 6 is 54. Okay, and 24 times 2 is 48. And negative 36. Look at this. Usually I add these and minus and add those, but look what I notice. If I just distribute that negative, I don't have to notice that, but they kind of gave me a clue. I was looking for that. So look out for those kind of things too. If I distribute that negative, look, what do we have? Oh, 54 minus 54, 48 minus 48, 36 minus 36. This equals 0. This is why you definitely want to do plain D first, because now you don't have to do all those other determinants. You're done. You're saying that Cramer's rule does not apply. No, Cramer's rule does not apply to this. And if you still needed a solution, then you'd have to go back and use our elimination and substitution to determine if it's infinite number of solutions or no solution. Right? And if you look right here, if you multiply this equation by 3, look what you're going to get. 6x negative 9x plus 12 equals 30. You can't have this equation equal 24 and also that equation equal 30. That can't happen. So it's pretty easy to determine which one is left. Okay, if this would have been exactly the same, if that had been, a 24 when I multiplied it, then it'd be infinite solutions because I'd have two equations exactly the same. Okay, so good luck with that and have fun. Let me know if you need anything.